Welcome to class number 5. And this time, as promised, I will do something with maybe your help in between. It will be just one very small exercise today. But as promised, I will show you something about Node-RED today. And I want to make a tiny bit of an experiment. I would like to be not, because usually when I show you this stuff, I'm super fast and then people come back and say, hey, what did you just do? So what I sometimes try is I want 2 volunteers and I will direct them to do it. Yeah, so instead of me kind of doing a lot of magic on my computer, I would like that one of you comes down with their computer and that we can actually record that. Good, so then I will show you kind of getting started in Node-RED and direct you while we are doing that. So we will just build 2 small things. Would you come? I will open that for you, so we just need to use the browser. And we could try out if the mouse actually works at the same time. So let me open up the page for you. So you have all discovered that if you go onto the ulno.IoT gateway, that you kind of have this web page where some things are installed, and there's Node-RED pre-installed. I encourage you to eventually also install a Node-RED on your local computer because you can hook up 2 Node-REDs with each other, and it's really easy to build these MQTT simulators in Node-RED later. But now I will just give you really the basic primer, and we use the Node-RED which is pre-installed in the Pi. And see, you just click on Node-RED, and it will ask you for username and password, and the default password on the ulno.IoT Pi image is username ulno.IoT and IoT Empire. Good. And make this a little smaller here, and I think at this point I will just make you an empty thing here. We call that test, and at this point I can hand over to the students. So who wants to be the master of disaster? And then we need another chair. No, we don't have another chair. Why don't we have 2 chairs here? Good. Do you want to guys have your names on the video or going to be anonymous? Else you're relative wurscht. Okay, what was your name? Bernhard and Harald. Bernhard and Harald are now kind of my assistants who will help us to be not too fast with Node-RED here in class. So you see in Node-RED, you see on the left side different nodes. So Node-RED is all about nodes and about the data flow between nodes. And the hello world of Node-RED, I don't know if some of you have watched the video, is actually an inject node. So maybe just take this inject node up there and put it over there. The cool thing is in Node-RED, so if you double click this now, you see always a little bit of parameters and documentation. So you see on the right side that there's the node help. So you could actually scroll down there. But so the injecting node is actually if you manually want to interact with it or if you want to trigger some data coming in automatically. So later we will actually use our devices here and get via MQTT this stuff. But for the beginning we will take just an inject node. Okay. Yeah, this is actually okay. Just say done. And now take a debug output node down there. To the right, exactly. And now just connect these 2 with each other. Very good. And that's basically the hello world. Make sure that on the side tabs there you have the little bug there. So basically over there. And say deploy now. And now press this button next to timestamp. And there you see, so we basically have a message. So if you want to have hello world, we actually have to change this. So just press a couple of times the timestamp. See, yeah, great. Forget it. So, no, now let's look. Just click somewhere, we have to select this. Find a change node. You can also search up there. You can just type in change if you want. Yeah, and it takes the change node and kind of insert this in between. Yeah. So kind of exactly, and double click on this. So you basically want to do we want to do hello world. So just replace replace it here. No, this is message payload. So replace message hello with hello world. So in the string here. Yeah. Great. So say done and say deploy. So always deploy after you've done that. And yeah, fire the timestamp thing. And you have to roll down, or just press the button for the garbage bin. Oh, what do you see?
My hello world.
Yeah, so hello world works. So let's become a little bit more complicated. For that, I want to connect one of my devices, which I prepared for you. And this will actually generate something via MQTT when I press the button on here. So let's kind of give this power. Yeah, that looks just really cool. Actually, all the devices are connected. I will show you later in this class how these devices can be connected. So this is booting up. And okay, so how would you guys now actually find an MQTT input? What would you do? You have already used
MQTT.
Yeah, just type in MQTT over there.
Ein Output brauchen wir jetzt.
No, input. You want to actually, we want to now see the button. So just wire the button already to the debug thing there. Okay, and now we have to edit the MQTT a little bit. So there's a host defined. So if you need a different MQTT host, you have to actually press this edit button over there. But we already have that, so just do cancel because the local one is predefined in what I've installed for you. So and then there comes the topic, and we don't know yet. So for this, we just put a pound sign in there because then it does everything. Pound is the shift 3.
Achso.
Yeah, and it's an English keyboard. Sorry, done. Done. So deploy that and empty all the messages in there. There we actually see already the distance thing here. And let's see if we see the button coming up there. Okay, what topic does it say?
Where do you see the topic?
Test 1 buttons.
Ah, yeah.
So, okay, just change the topic there and say we want to actually list for test 1.
Distance.
Test 1 button. Button 1, yeah? Slash button 1. Slash is here.
Ah.
Button 1. Okay, done. Done, deploy that, and let's see if we then now get only the button. Can you delete that? See, now we actually get only the messages from the button here. This is only, you can all do that. You all know what is actually happening in the background now, but now we actually catch the button. So, I have to show you something because you're watching, but you have to actually write something down in the in your lecture record. So because of course you need to help your colleagues here, and because later we want to actually, so we will now connect this button to a light. Yeah, so we'll actually just do that. We've been pressed that the light comes. But you have to help and actually figure out how can we actually toggle in Node-RED, because that's a little difficult. Yeah, so you have the task actually to help your peers here and actually Google now how can we toggle in Node-RED so that you can give us instructions how we can later toggle. So while we are working here and recording this, we want to have your help how to toggle. I think I had some, try to help. Also, it would be good if you have some idea or questions if you interrupt us. Yeah, we will now continue to show you more and more, but you might get some ideas for your own project. So write down some questions and ask them at some point and say, how could we do that? And we will try to address this. Okay, let's continue. We first want to now make an MQTT output and just connect the two so that we can actually switch the light. And this is where we are working here. So for that we need my other device. So I have configured this as an LED with an output. Okay. Do we have some more USB ports?
There is no USB port left.
No way, but here.
Here.
I have lots of USB ports. I just don't know how to plug this in. Did it blink? Yes. So I don't know if you guys can see the light. We will now try to switch this on and off, yeah, with the other button. So why don't you create an MQTT output? And I just happen to know that this one is test2 blue and set behind this. So just put in there test2, 2/blue. And you need a set topic /set.
So.
Yeah. Because on blue it reports its internal state, and on set you can actually change the internal state. So say done. So the problem is this guy takes on and off, and you're getting actually pressed and released. So you have to, this will not work yet. Okay. So you need a kind of change node for doing that. Take the change node, and yeah, wire it in between. And then now you go into the change node, and yeah, guess a little bit what you want to do. Now you don't have to do set, you have to do change, yes.
And we have
pressed and released. So pressed. We want to do on. And now you have to add another rule, and we also change released to off. Say done. Deploy. And I don't know if you guys see this. Yeah, see LED. If I press the button, the LED goes on. So we're nearly done with the hello world. We just need your little idea now how we can do the toggle. So I'll show this to the camera too. I switch it on when I press it now and release it now. So that's pretty good, but it's not exactly what we want. We want to actually press and then toggle the state of the LED. Have you found something? How can we do toggle? We need to save the state. And how do we do that?
You have to create a function node.
Yeah, function node. Very good.
And then you kind of store the current state. And
what do we have to do in the function node? All right, let's explore. So let's see. So double click on the function node. Let's see what it is. Oh, that looks like JavaScript, doesn't it? So we need to do some magic JavaScript. Did you find something how to do it? What is the main element to do the storage? Have you found that? There's a context element, yeah? So how, I could copy it now, but I always have to look it up. So how do we access the context?
You can type in context.state.
Mm-hmm. Yeah, no, I think so, like this, context.state. Sorry to give, I think I can switch to the German keyboard somewhere.
Easy.
And then get or set, or what do we do on the state?
you can just say context.state equals.
Okay, okay. I usually do it differently, but let's try it. Now we have to actually read it first, yeah? So we have to check if context state is, we want to do a toggle. Yeah? Okay, then we have to actually check, before you use that, make a line on top of it. Just so. No, the C is, yeah. And I can tell you that the content which is sent to the node you can find in message.payload. Yeah, so let's do an if message payload equals pressed or so. Mm-hmm.
Equals.
Gleich.
Right.
It's JavaScript.
Yeah, it's not so important if it's defined. If it's undefined, you want to have 3, so you can use here. And in quotation marks, so quotation is shift this key. Yeah. We want to switch if it's released, yeah? Released, and then we need a curly brackets, I think, like in C. This is shift this. Mm-hmm. Turn. Yeah. So we want to actually change, if we get this, we want to change the contents. So we can now actually check this if context state equals, or three times equals on, we will turn it into off, and else vice versa.
So I could have put in there or...
Now if, just an if before this. If context, is this okay? Are you following?
Is it correct that the message is written out, or is it just
It's MSG, you're right. Very good. Good remark. Put into lecture notes. Found mistake.
On oder was?
No, yeah, and on, just make it in quotation. And closing bracket.
Geht das mit denen auch, mit den
Ja, das
einfachen?
wird auch gehen.
I think it goes, you can use both.
Okay.
We're in JavaScript, everything is possible. And okay, so then we just say context state, we sign it the off. Bernhard must really kind of rethink in his head with the English keyboard. Semicolon, yeah, and then else down there. Yeah, we turn it into context state equals on. And semicolon, and
Das gibt eigentlich keinen Sinn, gell? Das ist ja schon an.
and then we want to actually at the end of this get the
But it doesn't make sense now when it's only. So okay,
we want to put this into the message payload. We want to overwrite the message payload coming out. So just yeah, here just right now message dot payload. No.
Context state.
Is it? Yeah, context dot state. No, probably make an indentation there, then it looks kind of nice because it's still in the. Okay, say done. And let's test this now. Just let wire this somewhere in between the timestamp thing. Ah, this doesn't get. So turn this set message payload into released. Instead of hello world, make it a release so we can simulate the button pressed for testing purposes, and then wire it between that and the payload. Yeah, good. We should probably give the function a name. So as you see, actually, let's call this toggle. Okay, done. Let's deploy this and see if we are doing fine, and kind of remove all that, and now fire the timestamp. We get on, fire again, off, fire again. Good. So as our function works, we can kind of rewire this in a different way. So what could be the problem now? I don't want to continue right now. What can happen? You see here that we also get some other messages in between. You see there are lots of released messages coming in between, even if we don't press the button here. So what do we need to do to prevent that?
Maybe some debouncing of the key?
You're thinking in the right direction, but it's even easier than debouncing. We want to actually only get the messages if they change, because the debouncing is actually already happening. So we need something. So guys, how can we, yeah?
We could use a variable to store the last state and compare it with
We could do JavaScript, yeah, but there's an easier solution. So fast Googlers, what do we use in Node-RED to only do changes, to only forward changes in the flow? This is great if you have 20 students Googling for you, isn't it?
Yes.
I know it. That's not the change node. There's a special node which can actually just forward things that changed, and it has a super stupid name.
Ich suche jetzt auch den mit dem blödesten Namen.
We can just look at nodes. We don't use Google. We just look at what is available and think what could it be. It needs to be under the function nodes. We know it needs to be one of these guys which is there.
one of these.
No, it's actually not visible yet. Yeah, now it's visible. It's one of these.
Is it the slip? Because it has no. So
Somebody suggested RBE. Just let's hover over RBE. Yeah? Only passes on data if the payload. That might be it. So why don't you put this behind the test button?
here.
Now just remove some of the connections. Let's rewire here a little bit. No, just delete. Click and delete. Click and delete.
This also.
Yeah. And now kind of make some space here. Move this. Actually, but we don't need the change rule anymore. You can just delete the change rule completely. Now we need the output from button into the RBE. Yeah. Then we need our function node. Just detach that. No. Not in the end. It's always from left to right. We are in a culture which reads from left to right. So yeah, now it has to go into the toggle from left. And this needs then to go to the light and debug. Yeah. Put it to the light. Or, okay, we want to test first. So I don't know, wire it both to the message payload and this. You can make two connections here. You can clone things. Let's try that. Okay. Deploy. So let's press the button and kind of clear this. So we turn it off. We turn it on. See, guys? Off and on. So it works. Yeah?
Can you repeat the RBE node? What does this?
Can you double click the RBE node again and then show the documentation here on I? Click on the I and make this a little bigger here. So, yeah, I always forget what the acronym stands for. It's report by exception. And it basically only when the payload has changed. As long as you get the same payload, it discards what comes in. So if you always kind of think in traveling data packages, it's kind of a very message passing paradigm we do here. But this is kind of what we want in the Internet of Things. We have all these kind of reports flowing around and want to actually do something with this. So let's do a little bit of GUI. Yeah? So we also want to have now, if you open another tab here, up there, and let me kind of enter here on IoT Gateway. There's nothing behind. And then you can see that there is a UI. Yeah. And you see that I have, I pre-prepared some UI elements there, but let's now open here. We have the example. Now we don't need that. We want a new one. We want a test there. So, but just to see that there is some GUI. So let's go back to the actual programming. Yeah. So the GUI element. I have to tell you I installed a plugin which is called the Node-RED dashboard. So if you want to do GUIs, you use the dashboard. So go down here, scroll down with the further down. There's if you want the dashboard. So if you want to do GUIs, we want to actually take this element. So what should we do? Just a switch where we can switch things on and off. Yeah.
Okay.
Yeah. Let's take a switch. And for the beginning, well, we could also do a button. But let's do a switch. So let's wire the switch directly in the output. Okay, and now look, make sure that the switch generates on and off. No, this is. Can it do only? Let's see if we can also send a string. Yeah. So one on, and then we send another string, and here send off. So now we also have to make a new group to show in a different tab here. So it's done, and for this I have to show you. Click on this little symbol up next with the. Yeah, that's very good. So just go on dashboard. There's an extra thing for dashboard. Make this a little bigger so we can manage this. So you see I have an admin group and an example group, and in there some subgroups. So let's create a new tab. So let's call this tab test. That's what we are doing now. Test, update. And in the tab we need a group. So let's add a group. We will also, for confusing, call test. test, update, and great. And now we take the switch, which is probably now in the admin group, and move, so open the test group. Here. There's nothing in there, and open the admin group, and move the switch from there. Yeah. Great. And deploy that. So now we should have the switch in there. Left click. And let's check the GUI. And now it should be in admin here. Click on admin. There should be a test. See, there's our switch. And let's see. Yeah. Yeah, let's show it to the camera too. So that's how easy you build a GUI. And now we could actually use our phone and interact with our Internet of Things system this way. Any specific requests at this point? Else I will make a little break and give Ruben the floor. But after this, I will show you how we can simplify the device installations and do a little bit more Node-RED. So don't worry, we are not done yet. But yeah, thank you for your help at this point already. You can take your mouse back because I can use this little red knob here when I do things. I hope that wasn't too fast, and yeah, thank your colleagues. I think they did a really good job. And thanks for your assistance. I know it's a little boring to be the assistant, but I always like to have a second pair of eyes when I do that. Yeah, we have a guest here today, and this is Ruben Jube, or Dr. Ruben Jube. So he just, unfortunately for me as a professor, he just got his PhD thesis. Now I can't force him to do stuff for me anymore. So now I have to be nice and friendly, and I just have to make him my friend if we want to work together. Yeah, Ruben and I know each other for a long time. So Ruben has been a lecturer for me already when I was in Estonia. So Ruben was at that time much more an expert in design patterns than I was. So we both actually studied software engineering. So Ruben helped me out a lot in kind of doing my software engineering lecture, and always took over the part of the design patterns in there. And turned out that at one point we had this great idea to rename his PhD to include Internet of Things. But I think that is something he can explain to you now. And let's give Ruben the floor for a little bit to talk about his experience with software engineering and the Internet of Things. We both wrote together, so he's one of the 3 authors of the book of story-driven modeling. So I wanted him to kind of encourage again to use stories for the Internet of Things, and I think he will share some of his experience there. Doesn't do that, so let's go into presentation mode. Yeah, and so Ruben actually worked the last 5 years or 6 years at Enercast.
Yes, a company about renewable energy forecasting. And beside that, I finished my PhD, as Uli told you. So I had a half-half job, more or less, for 2 years. And yeah, my time in the university was quite a while ago. I think we met 2008, so 10 years ago. And I worked 6 years in the university and now 6 years for a company.
And the company is interesting for you guys because some of you are interested in doing the energy informatics afterwards, and I think the Enercast is one of the lots of companies in Kassel which deal with energy and computations. Yes, and I think that's a company where you want to look at if you study energy informatics. So you can actually ask Ruben some questions about this connections between mobile computing and energy and data management.
Right. I won't talk that much about the Enercast company right now, but if you have questions about energy forecasting, meteorology, or something like that, or if that's what you're interested to work in that field, so feel free to ask me afterwards. Yeah, and there always has been some kind of connection, even if in the energy field you have sensors and on the windmills, and so there was.
Yeah, now we know where my wind farm example comes from.
Right. I've prepared, I think, a short overview over my finishing work at the university, so that might be 10 minutes or so, but feel free to interrupt me if there's something special for you.
I haven't
interesting.
prepared anything you have to write down now. So maybe
Yeah.
it's nice if you write, each of you writes down one question which goes later into the lecture report. So come up at least with one question, even if you don't ask it, but just for proving that you have listened to.
So my topic, one of the main topics I started when I was working in university was story-driven modeling. I don't know how much you've explained about
But
story-driven modeling.
you guys know what a story is, yeah? And what a scenario is. I think that I did with you, and I kind of hinted at this thing that you can use it not only for Internet of Things, but for software development in general. It's kind of, I think what I told them is it's very similar to test-driven development, and I think that's where they can relate to.
And as you can see on my title picture, I've also worked a lot with robots. So I've built a robot demonstrator, which won't be the topic of this short talk. Let's focus a little bit more on the IoT part. And I think it started in 2008 when some of our artists in the university came up with these nice microcontroller boards. It was the predecessor of Arduino, and since then we try to build stuff in our department, like the temperature sensors you can see there, and also
this is a
the robotic.
THT22, so you guys work with the 11 and this is a THT22.
Yeah.
See, it's very similar.
And I work with some artists as well, so there's an example of this whole LED fancy stuff, which were side projects where we try to apply the software methodologies we developed, like story-driven modeling, also with people who are had not computer science background. So story-driven modeling, I think, plays strong if you talk with people from other fields and try to design the software they want to have, and that really helps to have a graphical representation. Is maybe one of the main parts of the story-driven modeling. During my first year in the university, we had a software development tool suite, which was a quite mess software, which was later on integrated into Eclipse, and there you see an example how this software was specified in a graphical manner. So here we see objects.
You guys have, you know what class diagrams are, yeah? So I've done that. So, and that was a tool where you could do class diagrams and object diagrams. What you see there actually transition rules. So it's a little bit like Node-RED. So you actually can use rules to transfer one, maybe say something about what these transfer rules are actually.
I think I will focus on the most interesting object there. It's not a class, it's an object. There's do you have a pointer here? A small one?
I have a really classic pointer for you.
I use the mouse. I'm
I
talking
mean,
about.
that's recorded, but if you want to have real hardware.
I'm talking about this. There's a pictogram of the robot. Here you see the wheels, and it has a fork to attach things. And this object representation of the robot is part of the software specification. And you see there this robot is associated with a task, and it has to collect some of the goods indicated by this
Wine barrel?
Wine barrel, thanks. And it has to grab it and put it to some target field on the left side. And this is the blue parts are some specification you can talk about. Maybe with the customer is the ideal. It works sometimes, but the really interesting part of our software was that you can write these story patterns or design these story patterns in a graphical manner, and you get an executable code like it is in the Node-RED system in the background. So this really works after specifying such diagrams. Was the main idea.
It was not data flow driven like in Node-RED. You could basically say if you have kind of objects and then transfer the object space in a specific way. Because if you do object-oriented programming, everything is objects. And then you can kind of, in the relations between the objects and the story patterns was the idea, we transfer this into new relations between objects, or create and destroy new objects in there.
Another very popular theme coming up with the IoT as well was the rise of the agile methods for software development.
Mm-hmm.
I think was a really key part for my work, because the traditional way, we had a strong department of electrical engineers in our new university. They were following the classical approach: first specify the software for the whole system for 3 months, and then maybe a year later we start coding, and after all what we get wasn't what we wanted. So I think the agile methods with short iterations, quick prototypes, and visible results, or results which can be evaluated with the customer on very short iterations, is very helpful. For example, this this temperature sensor, which our electrical engineers didn't like. They didn't like the Arduino at all, but you could put it together. After 1 hour it was working. You could verify, and that was very effective if you deal with customers. I also did some experiments in different fields. This is an example for car communication. I didn't have access to real cars like pictograms there on the right. So the idea was that we built models. And you see these tiny robots again here, which drive on a, let's say, game field. It's a simplified traffic system of very simplified.
You have an intersection and you have kind of a beltway.
Yeah. And this project was set up like a game or a contest for game strategies. So what you had to do was grabbing these boxes here and driving them with the robot to the other side. And there was a virtual traffic light. So here you see the traffic light, which we developed later on, which isn't visible on the screenshot, sorry. But
But you know that kind of putting a traffic light with 3 LEDs in there would be a piece of cake for you now, yeah?
The idea was the 2 players or 2 opponents here, they have to decide if they take the way around or go through the crossing intersection, and if they choose the crossing intersection there might be a red light for them, so they have to wait. And it was quite fun what kind of different strategies or approaches the students came up. Even one group, I think they started with machine learning and artificial intelligence. It was totally weird, but it worked out. And because mainly of funding reasons, we had not so much robot kits at that time. But another aspect born of that, because we had so many, was we used the simulator. So the simulator was simulating the most important physical effects, like this robot here maybe drove too fast and lost his box. And the idea was that the same software which would run in the simulator, or the same strategy, could later run with robots. And we spent, I think, half a year to really include all physical effects which these robots had. But finally it worked out, so you could start up the simulator, develop the stuff at home if you wanted, and then go to the lab and try it out. Another scenario example of inside the software, here the traffic light is visible, which we hadn't in reality, so it we had it visualized on the computer screen.
Yeah, so kind of the point is making is that in the background we used a lot scenarios and kind of the images of the scenarios, the object diagrams, to drive the development. That's kind of what I want you to take away too, that yeah, it helps to draw things, it helps to write stories.
To give you a short overview over my work, what I finally found out, a very important part, which I didn't see at the start, was the prototyping. So we did a lot of these small experiments, one-day experiments to get something running. Some years ago it wasn't, I think the IoT theme has developed quite well, the integration gets better and better, but some years ago we didn't have MQTT and connection methods, so it was really important to get something running with serial connections or even more weird stuff, and therefore doing a prototype fast and evaluating what it is for is really a key point. Another key point, I think, is the simulation. Uli just showed you or verified the function of the toggle by pressing the button. But if you have more complex setup like the robots, you always have to maybe reset the robots if something goes wrong, and that's really anstrengend nach einer Weile. Ich weiß nicht, was das ist.
Difficult or strenuous.
So if you have a virtual test environment, that helps a lot. Having virtual robots, you can write a simulation which tests the basic approach, and so you don't have to set it up on over and over again. And what I really learned over the years as well was focusing on the hardware development. We did that for the robots a little bit, and this goes hand in hand with the software development, and therefore I don't know if this is about simulation. I will skip that.
Yeah, kind of start wrapping up, so the last 5 minutes or so.
Yeah.
The students are in total shock to have a lecture.
So I'll go back and explain this with that slide. What was really another great step forward was that we included in the software system not only objects representing our data model, but also the physical objects itself. Maybe there's now the popular term digital twin and so on coming in IoT. So the idea is you need in your software system representing objects of the things you actuate, for example, like the LED we've seen in the Node-RED. And this can be more complex, like whole car scenario simulators. Yeah, I think that's example scenarios.
Yeah,
you
just to see that he
had
has these scenarios in there.
You had them yesterday as well, I think. So
yeah.
This is a very concrete example. I won't go through the text
yeah,
now.
maybe it's kind of nice because that's very similar to what they actually have to do for the project now, to work with kind of building a very mini project. And I thought there were some people talking about open things, open garbage can, open windows or so. We could actually have a quick look at that. I think in Kassel you used often the examples which had to do with the university and the university room. And then what also was fun in Kassel, the coffee machine was one of the most central thing all the students and professors like to put in a lot of their projects. And you see kind of that, but you see how there are a lot of attributes, there's a lot of description going in there. And you also see what I told you yesterday, we want to always have it kind of a little bit in steps to be able to dissect it. That we don't have really the explicit start situation and explicit end situation, what I like to see, but even between us, we have sometimes disagreements how the perfect format of a scenario is.
Well, this might be a good start to translate into software, but yeah, it's missing the structure.
Yeah, no, but it's fine. So I think it's very good for them to see that and see kind of a different way of writing down the scenario. Good.
Yeah, and what we did after with such a scenario then translated into the story diagrams. You've seen the object diagrams, which I think are far more important than class diagrams. And I think, as you will see in this course, this is a very simple setup, what we see here with just the LED, or you haven't introduced the sensor yet. But these can get very complex, so you need some kind of hierarchies, maybe to encapsulate things.
Yeah, you might actually start drawing some things when you explain things to each other. And I think it will start, look, if you use scenarios as a base, you will very quickly, if you start drawing things and how things are related, come to the object diagrams. And even if you look at the wiring, I think it's a very natural match to kind of, basically draw the deployment diagram, which is very close to the object diagram. So to say, okay, I have so many VMOSes, and then the VMOS, I connect these devices, which is basically an object diagram. You just say, what are the real instances in hardware you are actually running.
It's not readable, but this on the right side, the yellow one is an object diagram. You can read it as well. That's the software we used some years ago, which was integrated in a debugger in the Eclipse environment, and now it's looking quite better in Node-RED, I think, but it was the same approach, having objects, having interconnections, filter objects here. So this gives an interactive system which you can modify on the fly at runtime.
Just to prove that our research years ago was actually very valid, as you see now that they're professional tools. Can you say some last words and give them a chance to ask some questions?
Last words?
No, so they say something again about the role for scenarios for your work actually, and for maybe also in what you're now doing in the company, and how far this way of using scenarios and stories has shaped both your PhD thesis and your work environment.
Yes, I think well, the most difficult part in creating software is not the software itself. It's about communicating what the software is for and how it should work. And scenarios are a way you could talk with someone who will maybe the end user of the software, how this should work, verify it, go into the details. So I think one pitfall is to abstract too early. So if you have concrete examples, then you have from the implementation side.
All went into this trap already, yes.
From the implementation side is a good entry point in coding tests, for example, because they are very concrete and.
And how far have you used it? So when you used it a lot in teaching in the university, is there anywhere in an example in your work where you have used stories for facilitating communication?
Not explicitly, sometimes not explicitly, but for example, last weekend we had a IoT workshop at the university the whole weekend, and of course it was a structured format, so we had agreed on 5 projects would be done, and they had big whiteboards on each side. So what we had there was textual descriptions what the system should do. That's a scenario if it's concrete. So this was a good entry point, and having it visible on the wall the whole weekend helped a lot to get through it, to get exactly done what we had planned.
Yeah, I've used it a lot in kind of hackathons lately to kind of get people on track and to do something very quickly, because in a hackathon you can only go to the prototype state, and it helps a lot to kind of have this as have actually story as a rationale. People are kind of more creative and come to some stuff quicker this way. Yeah, Ruben, thanks for sharing. I think we should give them kind of 5 minutes to ask 2-3 questions. Yeah, from a different perspective, who was kind of from a person who lived both in the academic and the industrial world. So maybe there's something he can share with you. Have anything IoT related or even just energy related we want to ask here? Yeah.
How many people were working on the car thing?
On what?
On the cars thing, Car2X.
Depends. 4, I think 4 were in the project.
Yeah, but you used it several times in class, did you? Or was it only a research project?
You've seen the demonstrator that was used for 3 years and maybe 30 students at all. And the students itself developed it. For example, there was a group who added virtual reality aspects, and that was a big step forward. And I think that was a group of 5. But I didn't really link these approaches to you've seen the keyword Car2X to the industrial research agendas. There are hundreds of people working on that. So.
And it's what you had a kind of grant or so at the university for that, yeah? And of course, you always kind of try to use it for teaching and for research, because that's the best benefit you can get if you can use your research for teaching and vice versa, because then you can justify all this time in a nice way. And this is a full research university, and there's obviously interest that you can do both. You also did a lot of hands-on thing. So I kind of grew friends with Ruben because Ruben likes to tinker with hardware and stuff. So I think that's also something we share, and what I want to actually give you guys is that actually working with hardware and trying things out, prototyping with hardware is fun. And
until it explodes.
Yeah, we actually haven't destroyed anything really yet here in class. So it's just Nearly unfortunate, but I hope it stays this way. Okay, Ruben, thanks for this. And let's move on to some more demo from me. Thanks, Ruben. So, no, I have a really small exercise for you guys. So I'm just a 5-minute thing, so don't worry, nothing serious here. But so last time we worked a lot with frameworks, and now you have kind of seen some things, have seen some more examples, have seen what Node-RED can do. I want you to now actually write down features you would like to see in an IoT framework. You have kind of looked at different frameworks and have seen some features which might be desirable. And I want you just to compile a small list of things you personally would like. So it's very important that you keep this list, because we will later compare this list, your personal list, with the list we will actually generate in class. So just 5 minutes. What are the features you want to see in an Internet of Things framework, so that you get the feeling that it really helps you to build Internet of Things systems, and also maybe maintain Internet of Things systems. Okay, some awesome dream features here. Why don't I start up there in the corner, guys? What each of you kind of gives a feature they want to see in a IoT framework. What should it help you do? I want to start back there. And then
I would like to work with wearables, and they can be integrated in those and stuff.
you want to actually have specific support for wearable devices. Okay, yeah, that's a good requirement. It might be for your projects. Good. Other requirements.
It would be nice if it's not so environmental. Like I want to sell a product, and it's a little bit.
And you want to have it not to have such a big environmental impact, or I don't know if I understood you correctly.
Yes.
Or German? No, say it in German. Ach so, also nicht so prototypisch und experimental. He wants it not to be so experimental and a bit more right away to the market. So kind of streamlining to actually making an actual product. Oh, that's a cool point. Okay, can I move forward? Something here in this group of people. What do you want? It's very high level stuff you guys
I would
want.
like to have some very good documentation.
Documentation, that's
Video
great.
tutorials.
Yeah, documentation, examples, and tutorials. Yeah, good. What do you guys want here?
I think there would be a mass deployment option. A mass deployment option.
Mass deployment option. Oh, thank you. That's a really important point. Yeah.
A good communication protocol between nodes.
MQTT is not good enough for you?
I mean, that's what I would like to see in the IoT framework, I guess.
Good. It's actually one of my major issues. Yeah.
Some kind of visualization to see the whole network of devices and which one are faulty or running.
Cool. Yeah. Yeah. Kind of an overview and kind of a management view of the whole network or the whole system. That's cool. Yeah. You?
Should be open source.
Should be open source, so you can make tweaks and change it and audit it. Yeah. Good idea.
Should be easy to integrate into existing systems like.
You guys listen, yeah? You can adjust your things.
Home, if this then to easy link to other services.
Integratable, so kind of works with others. Oh, very good point.
Security aspect is done by the framework.
You only want security, or do you want the other big brother of security too?
The whole security.
Privacy, yeah?
Nobody wants privacy.
No, do you want to? So it's actually kind of sometimes very hard to. So I think security is sometimes easier than making something privacy aware. Because privacy aware means that the users have to be privacy aware too. Okay. Anything else?
Self-hostable. So
Self-hostable, so that you don't need the cloud if you don't want to use the cloud. You had a point too.
The setup of a microcontroller should be easy, like plug in and it finds.
Yeah, this framework does support the microcontroller, and that you can actually do something with it. Good.
Good debugging features like when you make a mistake that it shows you immediately how to resolve the mistake.
Ah, now we're getting demanding. Good. Okay, let's see what I found, and maybe we can augment that a little bit. Yeah, see, documentation was a point I had too, and ease of use. For me, teachable is important. So it should be easy to kind of make others use the system. So that's a motivation for me. I want to be able to teach an internet framework to somebody else. I don't want to kind of set up hours and hours just to get an LED switched on and off. Affordability, nobody said. Yeah? So I think it should be, the framework itself should be not too expensive. You have worked with seen all the consortiums, and it was incredibly expensive. Open extendable we had. Scalable a little bit. Yeah, mass deployment we had. Nobody said testable. Yeah? No, she said debuggable, and yeah, so you basically mentioned that. Secure and private. I want a good communication protocol too, which for me is MQTT, but MQTT has a lot of downfalls. So I can actually not use MQTT for some IoT project where latency is an issue. So that might be bad. I would like to add some of the points you just mentioned. What was not on there? Can you kind of help me, because I forgot. So you had, Bernhard, you had a kind of nice point. You want this, a guided debugging, yeah? Oh, it's something a lot of people want, so I think it's a really nice point. There was next to you somebody wanted this overview about the whole system, wasn't it? Yeah. So we want kind of a debug guide, and we want this system overview, yeah? System maintenance. I can never spell maintenance. Yeah. But I think this maintenance overview. Okay, I think, did I forget anybody? Was this all the points? Anybody in there? Okay, good. Because I had all these requirements, I built ulno.IoT. And so finally you will meet it here in class. But why was actually the ulno.IoT created? So it was not because of all the points we just saw, but because of some of the points. And one of the most important points, I needed something for teaching. I needed something for teaching Internet of Things. And I had a lot of problems. I started just with the Arduino, and I did usually the stuff what you guys did here at the moment. And you have experienced tons of problems with debugging, with the serial cables not working, and kind of devices dying, and weird mistakes everywhere. Kind of some things with power, which are power related, didn't want it. And then I'm a teacher, I'm poor, yeah? So I needed it to be cheap. I have some time, but I don't have much money. And usually my students also don't have money, so I wanted something I can easily give to my students and didn't have to talk to a company, please, kind of give this to us for free. So I wanted actually something open source or for free. And so then openness came with it, with the idea. I used some other framework, like, so I looked at Mongoose, but I had no clue how I could actually change something in the framework of Mongoose, even if Mongoose is open source, or parts of it. I don't actually exactly understand what is open source of Mongoose and what not. So I wanted something I could change, or where I could be part of the community. And okay, I started doing it myself. And also one of the things, the extendability. And to be honest, I started doing all that stuff because of the ESP8266. Because I was in Singapore, I met a really cool maker, a head of a makerspace, who built an ESP8266 development board. And this must be, we looked it up yesterday, Ruben, I think the ESP8266 came out in mid-2014, yeah? And I think I met this guy 2015 or so when I was in Indonesia, and then I had a couple of trips to Singapore because it was easier for me to work there. And so this guy said, Uli, this ESP8266 is a game changer. This will change how you teach people. This will change how people develop products. And I think he convinced me. As a computer for $1 changes things. It's just at a price point where people suddenly think, okay, I can really put a computer in anything. And what was nice, he was an educator, he was also a teacher, and said, yeah, we have to prepare people to actually do that. And then I used his framework, and I had to do a lot of flashing, and kind of things went wrong, and it was very limited. I could only build very, very specific devices. I had nice teaching material, but I could just do one thing, so I couldn't unlock the creativity in students I wanted. But basically, using his material inspired me to say, I have to develop something new. And so that's how this stuff was actually created. We looked up ulno.net is from 2016. That's when I officially put the stuff on GitHub. I think probably a year earlier I started kind of gathering material and kind of combining things. But yeah, we're already working for some time. And guys, you can't believe how much I hate serial flashing. I just wasted so many hours of my life helping students to just get the serial cable working. So I think that's my biggest crusade, is not having to flash anything anymore, yeah? So a lot of what you will see now is guided by the idea, even if I will start now showing you how to flash things, but if you have flashed ulno.net once to a device, you don't have to flash it anymore. Oh, there it is. And kind of because I work story-driven, I always look at the examples and kind of do things what I do. There's one abstract pattern which arose, which was that I didn't want to teach the classic Arduino way. So what's the point? Is this guy here. Not the idea that this is a Raspberry Pi, but the idea is that we have a gateway. And that actually we always have a gateway and some connected devices. So for me, Internet of Things was never just one robot or just one LED I could switch on. So you have all these nice Arduino tutorials, which are really great to motivate people to work with hardware. But I think they miss one very important aspect of the Internet of Things, which is we want to build a system. We want to have something heterogeneous and some things which work together, which collect data. And so we have very different levels of hardware in the system, which work together to build something bigger. And that's why the idea of having gateways, which having different architecture levels in there, is so important. And the nice thing is, it turns out it helps privacy and security a lot if you have such an architecture. So if you take one thing out of my class, it is Internet of Things is about systems. Of course, it's also about data and connectivity and all this stuff. But I want you to take from my lecture, it's about systems. Because I like systems. I always loved Linux and networks. And when I had my own company, when I was young, I was actually trying to make networks work. So I did a lot of IT stuff. So I built routers. I brought people to the internet at a time where you couldn't buy routers. So I built Linux computers to do actually routers. And so there's this kind of this idea of connecting things together in a big network and to have then kind of a sum of it. That was something I always wanted. So kind of narrow it down. I wanted something affordable, accessible, motivating, and educational. This is why ulno.net was arising. And now you see kind of the current state. So you have this gateway. The idea is you have all the software on the gateway and all the development environment on the gateway. And you can then connect your computer to it, which you have already done. You have seen that these two, there's this Node-RED environment and this node management environment. So for me, this is a two-way thing. So if anybody of you wants to write a thesis and kind of merge this into one, feel free to talk with me. But at the moment, it's twofold. So we have kind of the integration part where we will use Node-RED for, and we have the node management part where we use this weird file system view, which I will demonstrate you now for. And then we have, so in my speech as always, we talk about the gateway, about the nodes, and about the devices. Yeah, so devices are the actors and sensors you connect to it. The nodes are the VMOSes or something else if you use it. And we have the gateway, which is the Raspberry Pi or one of your computers you set up as a gateway. IoT, the gateway software runs on any Linux-like environment. So even with some work, I could make it run on a Mac. It actually even runs on an Android phone under the terminal environment there. Good, so I will show you some stuff now. And of course, I don't want you just to watch because that's too boring for you. I want to actually check while I show you this, which features I am just showing. Yeah, so make another list for comparison with your features of the features I show you actually now, or I tell you now. I hope I have enough time to show all of this to you. Yeah. Maybe also, while you write down these features, also kind of write down some questions you might not ask right now, but which you want to ask in the lab. So can ulno.IoT do that? So can we do that with this? So kind of try to reflect what I show you now on your own project. Very sorry, I still want project 1 to be done manually. So you can use Node-RED for project 1, but still code all the nodes with the Arduino IDE. Next week you will start using also the node management of your IoT. Yeah, if you have time, I can do something special here. If you need a special sensor, we can try to live connect it here. Okay, I will hopefully show you now how the initial flash works with ulno.IoT. Then I will show you how, if you have already flashed ulno.IoT devices, how you can reconfigure them. I show you the over-the-air update. Also hint at the mass deployment option, which is there. But we don't have too many devices here to actually demonstrate that. Yeah, and then we'll connect different devices and see how the timing works. I think we have about 10 minutes to do that. Let's say 9 minutes, because I have one question afterwards. I want to ask you how many, in percentage, how many of your personal features ulno.IoT is actually covering, and one just have a hand count, 50%, 70%, or 100%. Yeah, so just for me personally, you see if I actually address some of your personal demands here. So there we go. Let's go to ulno.IoT. I think that's even something my international viewers will like a lot. So yeah, even if I hate flashing, we have to flash in the beginning because somebody else has destroyed everything which is on there with the Arduino IDE. So we have to get some initial thing from ulno.IoT on there. How does it work? So you go actually onto this initial web page here. So let's just remove all that. And for this, I have created for you a template example. Or let's just start at the home directory actually. IoT Empire. And you see either one or two panels depending on how big your screen is. So because I have the presentation screen now, I just see one. And so you see on there, this is the folder from ulno.IoT where I ran the install script. So ulno.IoT puts a lot of stuff here in local when you install it, but you basically have to don't care about it. So when you install it on your own computer, you check it out in Git. And if you have a Linux environment, then you can run the install script. It will download everything which it needs to actually do the compilation of the projects. So from there, you usually take in the library folder a system template. Yeah? So the idea is you have your whole system you build described in a folder structure in ulno.IoT. And in the system template, there are several nodes. I already created for you a system template, which is here this IoT test, where you can also jump in directly. And you see now, this guy here has 3 nodes. I will actually delete this one node because these are the 2 devices which I have set up here, test 1 and test 2. But I will show you how you actually create a new device and flash it and get started. So for this, you have to go into this ulno.IoT lib system template. And you just take the node template out of here. You just copy the node template, say copy, and now take this node template into your system which you are building. So let's just does it work if I just say here paste? Of course it goes in here. Great. Control X here, and then I go here into the IoT test and say paste here. Okay, now it's there, and now I rename this and we call this maybe our this is test 2. No, let's refresh it. Why not? So let's try with. Let's call this node 1. Yeah. So we were creating a new thing which is called node 1, and you see here in the key we actually have just some random things. So it will actually generate now when I initialize it a new key, and the key is unique for each device. So we'll have security in updating things. Only if you know the key, you can actually update the device and put new software on there. And here's a setup file. So there's a lot of stuff in the setup file. I will start with an empty one. So you can actually uncomment things in the setup file, or you can start with an empty one. So let's kind of edit this. And I will just, let's just nearly remove everything apart the first device. Where's the output? Here. Take this. The only thing I leave in there is the output. So this is actually a valid configuration of a node. You have a guess what this is doing? It defines the LED, the onboard LED. That's the stuff we want. How can you verify this? Yeah, so usually you want to check with a command which is called uhelp what devices there are. Yeah, so if you check here, there are lots of different devices you can actually use. And see, there was actually one device which is called output. Where is this? Here. So you have output here, and so it means you can actually call uhelp output. So what you usually do if you have a new device, you check if it's supported there, and then you read about it. And see, we have output here, and you see the general format, how the output command works. And you can also address it with LED or just out or with relay. And then you usually have an example. So what you usually do is you take this example and copy it into the setup code. Take this and go to the setup code. And so see, that was this format, but I will actually take the one I had here before. And you see, actually, usually you have the on command first and then the off command. Yeah? But because you know the onboard LED is inverted, that's why I invert the on and off commands. So that's it. I save that. What is this after there? I can already give it its initial state. Yeah? So if I say a set, .set behind that, I can actually say that it has a default state when it switches on. So, and now we want to flash that. So we will actually make sure we are in the right folder. So this, so you must verify that you are actually in the node 1 folder. And if you now type initialize serial, it will actually write to a locally connected device. So that means actually I have to take this device and it's actually, I wanted to show how to adapt this device. Okay. Let's go back. We wanna, let's reconfigure this device. So I take this device here, yeah? And we will just enable the LED on that one now. We take this device, plug it in, say initialize serial. Initialize serial. So then the magic starts to happen. It kind of now pulls together a lot of libraries and dependencies, and it will compile. Yeah? So basically the only input you have given is the setup CPP, but it also knows your internet configuration. It also already puts all this configuration automatically on there, and even knows the topic names, because it derives the topics names out of the folder name you give it and out of the names you give the specific devices. I'm too slow. You might have to continue next time. So I think I will move the hand count to the beginning of next lecture. I will just show you the adoption and we will just continue there afterwards, because you will not use ulno.IoT anyway until the weekend, but start next week. So I'll just show you that we actually successfully flashed this device, and then I'll show you next time how to adopt it over the air without actually flashing it again. So let's just quickly verify this. So this is called now Node 1, and I have prepared something for you. So if you look at the Node red stuff here, you can see that Node 1 okay, we can just do it without Node red. We can use MQTT send. And this needs to be sent to Node 1 blue. Let's send off and see if it goes off. I don't know what is going on there directly, so let's hope that works. Actually, we don't need the start of it. Oh, set. Because I forgot. Yeah, so it's off. And it's on. And it's off. Okay, a Node red, I made just a stupid mistake. I don't know what, what I did there. But so we successfully, very easily flashed the device. It automatically connects to the Wi-Fi network. It has all the configuration data. It's secured with the key. And I will show you how to do the over-the-air update then on Tuesday. Make sure to keep your notes so that you can still compare with your feature request list.